we have that the author obtained times of sleep of 12 randomly selected adults. The summary statistics for this sample are the sample mean 6.83 hours, the sample standard deviation 1.99 hours. Use the critical value method with a significance level alpha equals 0.05 to test the claim that the mean amount of sleep for adults is greater than 7 hours. Assume the population is normally distributed. This sentence will be there every time that the sample size is not greater than 30. If the sample size is greater than 30, then we don't need this assumption. So what's the claim in this example? Or first, how do we know that this is a problem about a mean and not about a proportion? What's the key word? The key word is mean amount of sleep. Okay, this is not a proportion, it's not a percentage, it's not a probability, it's a mean. So if it's a mean, we're gonna use the notation for mean, the Greek letter mu. So what's the claim? That the mean is how? Greater than 7 hours. That the mean is greater than 7. So that's the claim in symbolic form. So now we can write the hypothesis, the null hypothesis, and the alternative hypothesis. Where do we write the claim? In the null hypothesis or in the alternative hypothesis? In the alternative, because we have the greater than symbol. So what would be the null hypothesis? That the mean is equal to the 7. Always in the null hypothesis, we use the equal sign. So in this case, the claim is in the alternative. Now we need to find the critical values or critical value depending on the type of problem. So what type of test is this? Left tail, right tail? This is a right tail test. So how many critical values do we need? 1 or 2? Only 1. And is it going to be positive or negative? It's positive, very good, because the rejection region is an area to the right. Since the test is right tail, the rejection region is the area to the right of the critical value. And the critical value is to the right of 0 because 0 is in the center. So this number is going to be positive. Remember, the critical value is the number that separates the non-rejection region from the rejection region. So to find the critical value, we're going to use table F. So in table F, we use the value of alpha and the degrees of freedom df. So what's the value of alpha? Alpha is 0.05 and the degrees of freedoms are n minus 1. So the sample size minus 1. What's the sample size? What's the value of n? N is 12. So df will be 12 minus 1, and that is 11. So now we can use table F. Alpha is 0.05 and the test is 1 tail, and df is 11. So what would be the value? The critical value is 1.796. So in this case, the test is right tail, so we only need to use the positive critical value, 1.796. What's the next step? Now we need to find what? We need to find the test value, the test statistic. So using the right formula, T equals to the sample mean minus the value of mu in the null hypothesis over the standard deviation divided by the square root of n. So what's the sample mean? What's the value of x bar? Is given 6.83 minus what's the value of mu in the null hypothesis? Remember, this value is always the one in the null hypothesis, so 7 over the standard deviation is 1.99 divided by the square root of 12. Now remember that to use your calculator, you need to use parentheses on the denominator. If you want, you can use parentheses also in the numerator, or just write 6.83 minus 7 and then click enter or equal. So then you press the division, open parentheses, 1.99 divided by the square root of 12, close parentheses. So what did you obtain? If you round to 3 decimals, yes, rounded to 2 decimals is negative 0.30, and rounded to 3 is negative 0.296. Okay? In the homework and in the test, it will say the rounding rule. So always read carefully. Sometimes it will say round to 2 decimals, to 3, to 4. So in this case, it's negative 0.296. After you find the test value, you need to make a decision about rejecting or not the null hypothesis. So we need to see where the test value falls. Does this value fall in the rejection region or in the non-rejection region? In the non-rejection region, because the negative 0.296 is less than 1.796, so it's on the left side. The test value, negative 0.296, is less than 1.796, so it's in the rejection region, in the non-rejection region. So what will be the decision? Reject H0 or fail to reject? We fail to reject the null hypothesis. So now let's write the conclusion about the claim. We fail to reject this hypothesis. We cannot reject it. So if we cannot reject this, can we support the claim or not? We cannot support the claim. So the conclusion is that there is not enough evidence to support the claim. If we cannot reject that the mean is equal to 7, we cannot support that the mean is greater than 7. Okay, so we have the solutions step by step, the hypothesis, the critical value, the test value, the decision not reject the null hypothesis. So there is not enough evidence to support the claim. that the mean amount of sleep for adults is greater than 7 hours.